Hello everyone. In our video today we're gonna talk about the basic. On my last video I told everyone that I was gonna compare the charge controller, but listening to my friend Pierre Richard, so soon I'm gonna present you PRT. He will be with me on a video. So yeah, from his advice, I just want to start a basic video because he said, why you go that deep instead of giving the basic for anyone who doesn't know how to connect solar panel together, how to install a system to be able to install it. So, listening to his advice, today I'm gonna present you to everyone who doesn't really know, from 0 to 10. We're gonna talk about how to install a solar panel. I'm not good in drawing, as you guys can realize. So here are the solar panels. That's all we need in order to save energy. We're gonna talk briefly about electricity, like AC and DC. Those are the two type of current that we have. So AC is mostly to transfer current from long distance, pretty much from one point to another. So but DC is most likely to save the energy, to save it as a form of, like, even you use the solar array or you use the generator, you can charge batteries and then save the energy for using later. So DC allows us to save energy, but AC does not. So that's the big difference. But most likely all appliances use AC at first, but they get the parts like that transfer. You have bridges or diodes or transistor that transfer the AC, or that convert, the AC into DC. So meaning most appliances use DC to work. But in order for the current to travel from long distance, they use it as AC through the wires, and after a while they will have to change it back to DC. So all batteries are DC, pretty much. All batteries are DC current. You have a plus and a minus. So that's the difference. AC still have a plus and a minus, but it's not that important, because on the sine for the AC, last time I was talking about the sine wave, pure sine wave inverter, the AC sine is like this, pretty much. So you still have positive and negative. I'm not good in drawers, once again. You still have the positive, the one on the top, the waves on the top is the positive, and the bottom one are negative, but it's kind of neglect. You don't really have to pay that much attention to it. So that's the difference, AC current. It's like in all testers, in all AC, and then DC got the presentation like this. For you got a plus, sometime in the tester, multi-tester, you have a bar and a bunch of, to show you that it's not continuous, So that's DC current. That's the presentation. In most multi-tasters, this is how you're gonna see them, that's AC and DC. So yes, that's about it. So battery allows you to store the energy, and then AC allows you to transfer the current on wires or cables from long distance, like for long distance. Okay, so that's pretty much the difference. But the only difference, the AC positive and negative is not that important that you can neglect. You don't have to pay attention to it really. But for DC it's very important, because if you misuse the cable, you're gonna set the place on fire or make batteries explosion or whatever. Okay, so that was our little electricity reminders. Boom. Solar panels give DC current, so therefore there's a positive and a negative. and charge controller use the solar panel current, because the solar panel current, it varies like that much. You wouldn't charge the batteries like the way you guys want it, really. So here I forget to put batteries. I put BATT just for batteries. BATT. Those are the batteries, okay? And then they have specific batteries for DC, and then they have, they have specific batteries for inverters, which is a little different than the car batteries, because most inverter batteries got more capacity in terms of saving energy. And yeah, some people use car batteries for their solar system, but it's not gonna last long, because car batteries weren't built to, like being charged over and over and over and then discharged that often. So yes, we got the solar panel, we got the charge controller, we got the inverter and the batteries. Like both guys will get the connection directly to the batteries, okay? So the charge controller charges the batteries, and then the inverter use the batteries current to give you AC, so you can use all your appliances, the whole house, lights, everything. So that's pretty much the thing. And then connecting solar panel there's a little trick. You can connect them in series or you can connect them in parallel. In series means it's like we work in series one after another. Like you got the plus here, the positive, you just connect the negative from this solar panel to the positive to the other one, and then now you will have, they will they will work like one big panel now. Let's say in series you just add the voltage, like the voltage will add up, but you can connect in series two identical solar panels. Remember, even for batteries, you connect in series or in parallel two identical solar panels or batteries. Very, very important. For a charge controller, it doesn't matter. When you have to, it's gonna be in parallel, hopefully, but you don't have to have the same identical solar panel. It's not that important. But for batteries and solar panel, you definitely need the identical, solar panel or identical battery to add them in series or in parallel or in series parallel. And then for charge controllers, once again, it doesn't really matter. So yes, in series, so we're gonna have a series connection now. Series, okay. So okay. Anyway, in series connection, you put the minus from this panel to the positive, you add them together on this panel, and then now they're gonna be one big solar panel with the voltage. Let's say this one was like 24 volts and 24 volts, so now we're gonna have a 48 volts solar panel, and then we're gonna use this positive to send to the charge controller. Positive, respect that's DC, very important. And then this negative, okay, I'm gonna cross them over, but you're gonna figure out it's the same. Negative here, okay, it's gonna be 48, for example, volts. And then usually those charge controllers got multiple entrants, like their input may have 12, 24, 36 or 48, whatever, 60, whatever it is, but it's just yeah, that's the point. Okay, so now yes, now we're gonna put the I'm gonna give you the difference between parallel and series, and then you'll figure out which one works better for you, and then you'll do it in the future. And then for parallel, even like series and parallel, you'll still use them as one. You'll still connect multiple things as one. So here, for parallel, we're gonna add the positive together. Positive, positive. You won't burn, don't worry. Positive, positive. And then negative, negative. Okay, that's how it is. And then now you can connect if you have, they usually give you a Y branch. The Y branch makes it better. The Y branch connector or parallel Y branch, it adds like, you got the MC4 connector, you just plug it into the solar panel and then you'll just add them in parallel easily. So, yes. And then now you're gonna have one negative going to the negative of the charge controller and then one positive going to the positive of the charge controller. Once you put them in parallel, if it's not through a Y branch parallel cable, if it's not through the Y branch parallel cable, it doesn't matter which side you use, but you use one negative and one positive. Okay, so I can use, you see, this time I choose this side. I could have used, oh, let me do it over real quick. That's a negative here. Okay, we could have used either side. Okay, we do it. Boom. We could have used here. It's the same. We could have used the negative here, and then take this positive here. Once they're in parallel, meaning they work like one. Like the positive works together, and the negative works together. So that's pretty much about it. Parallel connection and series connection. So now let's talk about the charge controller. The charge controller has the job to regulate the DC current provided by the solar panel and then send it to the battery. It adjusts it through the battery. So the first thing to connect is the charge controllers to the battery. And I'm going to show you quickly how to, it's the same thing, how to add the batteries in parallel or in series. It's the same exact thing. Let's say each of these batteries are 6 volts. Okay, 6 volt each one of them. The same type, same exact type. Each one of them. Okay, 6 volts. Okay, so in order to, and then let's say we're using a 24 volt system. These solar panels are 24, each one of them. Okay, 24 volts. 24 volts. Okay, right here. Okay, you guys understand pretty much. Okay, so it's the same thing, same scenario. We want to make 24 volts. Our charge controller supports like 12 volts, 24 volts, for example, and let's say 48 volts, 48 volts. For example, okay, or 36, whatever you want. Let's say, okay, let's use 36 because that's 36. Let's use 36 volts. Okay, the charge controller can automatically detect which type of battery, which voltage of battery you provide, and then it adjusts it to charge the batteries from the solar panel. So that's the thing. Okay, so our charge controller supports all of these voltages, 12, 24, 36. So we're gonna make a 24 volts solar system. So therefore, okay, with the 24 volt solar system, our solar panels are 24 volts, and then we just have to, we can have them in series or in parallel, depends on what type of charge controller we use. If we're using a PWM charge controller, they have to be in parallel because PWM doesn't give you that much, you know, like voltage ranges, okay? But we have to put them in parallel, positive and positive, negative connect to negative, and then we got one positive going to the charge controller and then one negative going to the charge controller, as I shown before. But if we're using, most likely I would suggest everyone to use the MPPT charge controller, MPPT, okay? Because they, what the good thing about them, the excess of voltage they have, because even the charge controller said 24 volts, when you test them, when you use your multi-tester, you're not gonna find a 24 volts really. It's gonna be way more than 24 volts. It might be like 36 or 30 something, or yeah, 36 most likely. So the charge controller will regulate those, you know, excess of voltages for the MPPT, and then the excess of voltage, it will change it, convert it to amp, to current. So that's the good thing about MPPT charge controllers. But if it was a PWM, it will just regulate it. You got the excess of voltages regulated to 24 volts, but it wouldn't give you a big amount of amp. Depends on the amp receiving, it will just give you let's say if it's like let's say a 20 amps charge controller, it will just give you 20 amps on the output. That's the PWM. But the MPPTs are better. They just give you the excess of voltage they have, they change it into current. And then you know what charges the battery is just the current. In cable, by using a 12 volt, then a 20. Because the 20 volt, once again, the charge controllers, because for the 12 volts, still the charge controller can regulate the 24 or whatever you give, if it's a MPPT 48 volts to 12, but the loss will be considerable. You know, the loss in the loss in terms of current will be high. So we don't want that anyways. Okay, for our 24 volt system, one battery 12 volts, okay, and then down here the same, positive, negative, another battery 12 volts. So and then now, since we're doing a 24 volt system, we're gonna still add a positive to negative. That's the trick. We have two batteries, one here, another one here. That's how it works, okay? And then now the thing is, you have to still put them in series in order to have 24 volts. Because now if you test the batteries, you will find 12, like positive, negative. If you're using your multi-tester, you will find 12 volts, and then here 12 volts. So in order to have 24 volts, you still have to add them in series. In series, the voltage goes up, the amperage stay the same, but in parallel, the voltage stay the same, and then the amperage goes up. So that's the difference between series and parallel. Okay, now we'll have to use this negative goes to this positive. So it's like we're gonna have one big battery, 24 volts, and then we're gonna use this negative here, and then this positive here to go to the charge controller. Okay, so you use the negative, very important, go to the batteries, negative, boom, and then the positive here, stay straight line, goes to the positive. First things first, you connect the batteries to the charge controller, and then a light will, you'll see a line, or the screen will turn on, and then telling you whatever the voltage is, like maybe 24.6 or 24.8. okay, so first thing first. And then now you can connect the solar panel. We put them in series, but we could have put them in parallel also, you know. And then we put the negative secondly, that's the second thing you put, okay, and then you put the positive from the solar panel. You get the positive will be, that's just to show you, to let you guys know how to connect them. But in the future, maybe in the next 2 months, I will give you the practical aspect of all what we're saying here. And then now I don't mention the fuses so far, but from each one of them you need fuses. I'm gonna show you what type of fuse I use and then what works better. So therefore, let's just, in the positive, you put fuse in the positive side mostly, okay? F. I'll show you. So make sure you subscribe. Make sure you subscribe so you can see all the other videos that will come in the future. I'll show you which type of fuse is better than others. And then in this positive here, we also have to put a fuse, because the fuse help protecting your equipment, because if you don't put any fuse, you might blow up the charge controller, or you might set the batteries on fire. But if there's a misuse or whatever, like people will drop some metal on the batteries or on the wires here, it'll just blow up the fuse, and then you'll still have your batteries, everything will still the same. And then now we're gonna do the same thing. I'm gonna tell you which type of connectors to use from the battery to the inverter. This one is very important. The inverter use a bigger sizes, because let's say if we're using for the house, it might be at least a 3000 watt inverter. If we at least a 3000 watts inverter to hook up the whole house, in the future I'll tell you more about it. And then you still use the same. The positive here goes to the positive directly, because in this diagram you won't be able to see what I'm talking about, but this wire should be at least of size 4 or 2 or 1, depends on the load you're gonna put on the battery. You still put a fuse here on the positive. Oops. Anyway, you guys understand what I'm saying. Let's put a fuse F. Okay, put a fuse here on the positive side of the battery, and then the negative goes to the same negative we've used earlier. Okay, this is wires. Don't make it a big thing, because all wires are protected, they are covered with plastic or other things. Okay, so that's pretty much it. That's the connection. You use the batteries, you add them in the voltage you want the system to be, you add them together, connect them to the charge controller, and then after you add the solar panel the same voltage you want it to be, you add them to the charge controller, and then now you can connect your inverter to those batteries, and then those solar panel will charge via the charge controller. The solar panel will charge the batteries during daytime, and then you will be able to use the batteries, will store the energy, the current, and then you will be able to use those batteries either during daytime or in the evening. But you just have to figure out what size of system you want. We'll talk about that in the future. So that's pretty much it for today. Videos, subscribe, and then tell your friend, share the videos. Thank you so much. For the next video, we'll talk about all the equipment we're gonna use, all the connectors we're gonna use for the solar system. Thank you guys.